Hello and welcome back to Mr. Lamb Science Corner. Today we're going to take a look at a lab. And while the lab is mostly science, it has a lot of math in it. So if you happen to have a principal that wants you to concentrate on math and not necessarily on science, tell them it's a math lab. But it's got some good science too. So basically what we're going to do is we're going to look at a pendulum and what causes the pendulum to swing back and forth. And if you want a good English writing assignment in there, have them look up Galileo, because he was one who did a lot with pendulums, including realizing that the pendulum swings at a very regular rate, and he used it to time things. Okay, and so it's just very simple. A pendulum, I'm going to take up the excess here, some of it anyway, then it will swing back and forth. And so what we're going to do is we're going to investigate how long does it take to go from here over to here and then back again. It's called the period. Okay, the time of one period is from here over and back. But we're not going to time one period. What we're going to do is we're going to look at it go, we could have it go 10 times, we could have it go 20 times. In general, the longer, the more periods you do would become more accurate. Well, as we can see, if I just hold it like this, it kind of, it kind of wobbles around and slows down and stops. So we're not going to hold it. Instead, we're going to take it and put it onto some type of thing. Now, if you want, there are pendulum clamps that are really good, but they run $15, $20 a piece, something like that. So you can go down to your local paint store, this happens to be Fred Meyer, and get a stick like this, or you can cut some, or whatever, and you can just take this and wrap it a bunch of times, and then I'm going to clamp it to hold it in place. So if you happen to have a clamp like this, that's great. If not, you can take a meter stick, which I don't happen to have, and put it on a table, and then put a bunch of books on top of it to hold it in place. Okay, you be inventive is what I'm saying, and you can come up with a number of different ways of holding this. But what you need something to where this can rotate about a fairly small point. Okay, so this thin stick works really well. And as we can see, it goes back and forth quite well. Okay, welcome back. We had to do a minor editing here because it turned out that my wife, who's the camera person, said she couldn't see the pendulum without a background. So hopefully this makes it a little bit easier to see. So anyway, so what we're going to do is we're going to swing this back here, and we're going to let it go. And you want to let it go for at least 10 times. 20 would be better. I don't know if you want to go 30 or not. It kind of depends upon the patience of your children as where they do this. Now this lab will work for, I know that in the 5th grade curriculum, at least in Oregon, they do talk about pendulums, but it also works in high school too. So you can use it for a number of different ages. I don't know if I'd go much below 5th grade, But it kind of depends upon the student too. If you're doing homeschool and you have a really precocious third grader, say, or something like that, maybe it'll work. I'm certainly not an expert in early childhood, so you know your students better than I do. The big thing that we want to make sure that we do is that we want to make sure that we test one variable at a time. You don't want to make a bunch of changes and then you try and see that the period has changed, and you say, well, it must be because if you've changed 3 or 4 things, you can't tell. So change only one thing. And I thought, and of course, feel free to improvise and to try other things if you come up with them. But one thing that you could try is how far back you pull this. Okay, try pulling it back just a little bit, and try pull and count the periods. And basically, you're just going to use a cell phone or other stopwatch, and you're going to go, and then you're going to stop it at let's say 20. And remember, that's over and back is 1, over and back is 2. So you do at least 10 periods and maybe more, but be consistent and write down the data, and then you can do the math later in a table. So try back and then measure how far it is. So it hangs down there, that's 0. Move it back, say 5 centimeters or thereabouts, and try it. Move it back 10 centimeters, and make sure that you measure this, okay? And you don't want to pull it back too far, say like up here to like this, because even if you don't hit something, a lot of times you'll get some shaking up here, and that will impact what you're doing. So there is a limit on how far back you can pull this. But you can get, say, a good 3 or so different distances that you pull it back. So does the pulling back affect the period? Another would be is the length of this. How far from the middle of the weight to up here? Well, with this, it's easy to adjust it. Okay, you can just do that if you've done it like this. Or if you have the clamp, you can unclamp and move it and clamp it back together again and like this. And then if you do this, you're going to pull it back the same distance for each length that you're going to measure. So pull it back, say 5 centimeters or 10 centimeters, whatever you choose. And then you can change. And I'm one that likes big changes, because if there's gonna be a difference, it's going to show up really well if you have a big change. So if I had something set like this, I would probably measure this, go back about 5 centimeters or thereabouts, and try it. And then after I do that, instead of just doing 1, I would do maybe 3, and then maybe, depends on how many I've got here, that's probably about as much as I want to, but I may go down all the way to the floor and see what sort of changes there are. Okay, and so we have that, and then you might want to take this off and change the mass of this. Okay, this happens to be a 1/2 ounce lead weight. They make lead weights for fishing. If you go down to the local sports store, you can find fishing weights of all kinds of different sizes. I'd use at least a 1/2 ounce lead weight. You get a 1 ounce, 2 ounces, 5 ounces, that probably would be enough to see if weight has a difference. Remember that if you're going to change the weight, you keep the length of the pendulum the same, and if you have a big weight, you're going to measure to the center each time. Okay, the center of mass each time. And since you're using lead weights, you might want to do a couple of different things. The minimum that I would do is have your students wash their hands very thoroughly afterwards. Soap and water, and spend a little time doing that. That's the minimum that you should do, because if lead is something that it's a poison to the system. It affects the younger the child, the more of an effect it is. They're not babies, but certainly it's not a good thing. You might even want to take and some clear fingernail polish and coat the lead with fingernail polish, maybe a couple of coats, so that the lead won't rub off onto their hands. That's something you could do. Also, I would, instead of using string like this, because you have to tie I don't know if it can show up or not, but you have to tie a knot in here, otherwise it unravels, and that's a pain. Another thing you could do is use carpet thread. This is button and carpet thread. It works pretty well, because it's tough enough to hold buttons in place, as long as you're not swinging the lead weights around or something like that. You're going to be doing okay, and they'll last for some time. Or if you if storage is a problem, then what you want to do is you want to just throw it away, and you can, because button thread isn't terribly expensive. So anyway, this is the setup, and if I set this out of the way here, we need to set up a table of some type. And let's see if I can. You probably want to have trial, and this would be a number like 1, 2, 3, 4, however many trials you have. And then what do you need? You're going to be trying the mass and the length of the pendulum, and you'll probably have to explain this. Is something called the amplitude. That's how far back you pull it. Okay, if you pull it back a lot, then it has a high amplitude. You pull it back a little, it has a low amplitude. So you're going to try these 3 different things, so they need to be in your table here, and you might have some other things that you might want to try in here. But so you're going to put the number. Okay, so trial number 1, and the mass is 1/2 ounce. And if you want to put it in metric, you certainly can do that. Don't forget to put the unit up here, and the length, probably, if you're going to use ounces, you probably should use inches. If you're going to use metric, you probably should use metric all the way through. Try not to confuse people by saying ounces here for the weight and centimeters here for the length. It could lead into problems. Do it if you think you can do it without too many problems, but probably not the best idea. And so you're going to of course, you'll have to do some calculations because this is, remember, wink wink, a math lab. So if you're going to do the time for 20, then the time for 1. Okay, so time for 20, time for 1. And then you might want to put something here like makes a difference, question mark, and you're going to, you may have something here, or maybe not. But somewhere along the way, you're going to need to come to a conclusion. Does the mass make a difference? Yes or no? Does the length of the pendulum make a difference? Yes or no? How about the amplitude? Yes or no? So you need to, that's why we need to have change just one thing at a time, because how else are you going to tell? So anyway, it's a great lab. Depends upon the kids, 40-45 minutes, something like that, to get pretty much all done, and then you can get them into writing up the lab report. There's formats and such for the lab reports, all kinds of different places on the web, and you'll see that most lab reports are written up pretty much the same way. So anyway, it's a great lab. It's a great science lab. It also makes a pretty good math lab too. So have fun.